Let's take another example. We're taking number 10. The following is an incomplete table for the relation y equals 2x squared minus 5x plus 1, and that's a relation. Question A says copy and complete the table. How do we do that? When x is minus 1, y is 8. When x is 2, y is minus 2. They already gave us that. When x is 5, y is 26. So we have to complete the rest. Let's see that when x is minus 3, y will be 2 into bracket the square of minus 3 minus 5 into bracket minus 3 plus 1, and that's 34. When x is minus 2, y will be 2 into bracket minus 2 square minus 5 into bracket minus 2 plus 1, and that's 19. When x is 0, y will be 2 into bracket the square of 0 minus 5 into bracket 0 plus 1, which is 1. When x is 1, y will be 2 into bracket 1 square minus 5 into bracket 1 plus 1, and that's minus 2. When x is 3, y is 2 into bracket the square of 3 minus 5 times 3 plus 1, and that's 4. When x is 4, y will be 2 times the square of 4 minus 5 times 4 plus 1, which is 13. So now it's good to add some more points to make it easy to draw the graph. We know that on the number line, if this is 0, this is minus 1, this is minus 2, this is minus 3, this is minus 4. Between 0 and minus 1 is minus 0.5. Let me just write it there. Minus 0.5. Between minus 1 and minus 2 is minus 1.5. Between minus 2 and minus 3 is minus 2.5. Between minus 3 and minus 4 is minus 3.5. So we can have values for all of that too. So that's why values of y for all of those x values too. So I'm doing that to have more points. When x is minus 3, y is 34. Let's complete that first. When x is minus 2, y is 19. When x is minus 1, y is minus 2. When x is 0, y is 1. When x is 1, y is minus 2. When x is what did I do here? I think I need to check that again. When x is minus 3, y is 34. When x is minus 2, y is 19. When x is minus 1, y is 8, not minus 2. When x is 0, y is 1. That's it. When x is 1, y is minus 2. When x is 2, y is minus 2. When x is 2, y is minus 2. When x is 3, y is 4. When x is 4, y is 13. And when x is 5, y is 26. So I'm just finding the values of y for the new point. When x is minus 2.5, y will be 2 times the square of minus 2.5 minus 5 times minus 2.5 plus 1, and that's 26. When x is minus 1.5, y will be 2 times the square of minus 1.5 minus 5 times minus 1.5 plus 1, and that's 13. When x is minus 0.5, y will be 2 times the square of minus 0.5 minus 5 times minus 0.5 minus 5 minus plus 1 That's 4. When x is minus 0.5, y is 4. When x is 0.5, y is 2 times the square of 0.5 minus 5 times 0.5 plus 1, and that's minus 1. When x is 1.5, y will be 2 times the square of 1.5 minus 5 times 1.5 plus 1, which is minus 2. When x is that's correct, 2 times the square of 1.5 minus 5 times 1.5 plus 1. When x is 2.5, y will be 2 times the square of 2.5 minus 5 times 2.5 plus 1, and that's 1. When x is 3.5, y will be 2 times the square of 3.5 minus 5 times 3.5 plus 1, which is 8. When x is 4.5, y will be 2 times the square of 4.5 minus 5 times 4.5 plus 1. That's 19. Okay, and that's it. So we can now join all of those points. Can now draw the graph of all of those points. It will be easier now to draw that graph. So let's go to the next one. It says we have completed the table. Question B says, okay, yeah, that's question B. Using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 10 units on the y-axis, draw a graph of the relation y equals 2x squared minus 5x plus 1. I'm going to use this app to draw the graph. Okay, and on the x-axis, the scale is 2 centimeters to 1 unit. 2 centimeters to 1 unit on the x-axis. Okay, that's 2 centimeters to 1 unit. And on the y-axis, it is 2 centimeters to 10 units. I can have that. 2 centimeters to 10 units on the y-axis. 2 centimeters to 10 units. That will mean 1 centimeter to 5 units. 2 centimeters to 10 units. Okay, that's 2 centimeters to 10 units. But my x-axis has been altered. 2 centimeters to 10 units. I should be able to have both. I should be able to have my choice of scale. Oh, I think that's good. Yeah. Okay, that's good. 2 centimeters to 10 units on the 2 centimeters to 10 units on the y-axis and 2 centimeters to 1 unit on the x-axis. Yes, that's the scale I want. So we're drawing the graph of y equals 2x squared minus 5x plus 1. 2x squared minus 5x plus 1, and that's a graph. So that answers question question B. Now question C says, using the same scale, draw the graph of y equals x plus 6. Using the same scale, draw the graph of y equals x plus 6. What you do here is you go to your table. That's question C. You can make a table of values for y equals x plus 6. Just choose any 3 values. I think that will be any 3 or 4 values of x and find the corresponding values of y for it. I'm just going to do I'm just going to do -1, 0, and 1. So you draw the graph of a straight line that represents that. So let's say that when x is -1, y will be -1 plus 6, which is 5. When x is 0, y will be 0 plus 6, which is 6. When x is 1, y will be 1 plus 6, which is 7. So I'm going to draw the graph of y equals x plus 6. So you just plot the point. When x is -1, y is 5. When x is 0, y is 6. And when x is 1, y is 7. You plot those points on your graph and then join them together by a straight line. So that's what I'm going to do on the graph. I'm just going to draw the graph. Y equals, I'm drawing the graph of y equals x plus 6. X plus 6. That's the graph of y equals x plus 6. So let's see what's the next question. Question D says estimate from your graphs, from the two graphs. The straight line graph is the graph of y equals x plus c, while the curve is the graph of y equals 2x squared minus 5x plus 1. Estimate from your graphs correct to one decimal place. Roman figure 1, the least value of y and the value of x for which it occurs. The least value of y and the value of x for which it occurs. The least value of y is the least value of y is the least value of y is the minimum value of y. So let me do this. Let's do this. Let me save that so we can now use it to answer the remaining question. Yeah, we can use it to. We can write on it. That will make it easier. Let's do that. Yeah, this is the diagram. Now from the graph, we're answering question C, question D now. D, Roman figure 1. The least value of y and the value of x for which it occurs. Question D says find, question D, Roman figure 1. Let me just write it here. D, Roman figure 1 says find the least value of y. That's simply the value of y, the minimum value of y. That's y minimum. The least value of y and the value of x for which it occurs. So we can do that, find that from a graph. Just go to the lowest point on the curve and trace that point to the y-axis rather. And this is what we're going to have if we do that. We'll see that that's you use a ruler to do that, and we'll see that that is minus 0.2. Sorry, that's -2 rather. The scale on the y-axis is 1 centimeter to the scale on the y-axis is 2 centimeters to 10 units. 1 centimeter, 2 centimeters to 10 units. That means 1 centimeter to 5 units. So this will be 1, 2, 3, 4, 5. On the negative axis, -1, -2, -3, -4, -5. So this is -2. So the least value of y is -2. -2. And the value of x for which it occurs, that's what we get when we trace this point to the x-axis. If you trace that up to the x-axis, you must use a ruler so that your line will be straight. If you trace that to the x-axis, what do we have? That is 1 point. On the horizontal axis, it is 1 centimeter to 2 centimeters to 1 unit. Okay, so that will be 1.1, 0.2, 0.3. Yeah, that's 1.3. So at when y is minimum, x is equal to 1.3. Now Roman figure 2 says the solutions of 2x squared minus 5x plus 1 equals x plus 6. What we do here is, the solutions of 2x squared minus 5x plus 1 equals x plus 6 are the same as the solutions, at the point of intersection of the graph of y equals 2x squared minus 5x plus 1, which is a curve, and the graph of y equals x plus 6, which is a straight line. So the point of intersection of those two graphs give the solutions of 2x squared minus 5x plus 1 equals x plus 6. So this straight line is a graph of y equals x plus 6, and the curve is a graph of y equals, let's label that, the curve is a graph of y equals 2x squared minus 5x plus 1. Now the solutions of the equation 2x squared minus 5x plus 1 equals x plus 6 are the point of intersection of the two graphs, and you must use a straight line to join that. So you trace those points to the x-axis. So solutions of solutions of 2x squared minus 5x plus 1, let me even write it under here, 2x squared minus 5x plus 1 equals x plus 6 are x equals, what's the value here? That's minus 0.7. Let me say minus 0.65, and x equals here, it is 3.6, 3.6, let me do 3.67, and those are the solutions. Those are the solutions of 2x squared minus 5x plus 1 equals x plus 6, and that's it, very, very simply.